We started a discussion about integration by substitution in the preceding video lesson. I give some steps to follow for us to integrate a function using this method. For this video lesson, let us continue applying this substitution to compute the antiderivative of some transcendental functions. Observe now this equation stating the integration by substitution. On the left-hand side, we have function g of x, and the derivative of such function denoted by g prime of x is also present on that same side. Take note that we make a substitution for a function whose derivative also occurs in the integrand. We will apply this technique in integrating functions with radicals. In this example, evaluate the integral of z squared over the square root of 1 plus z cubed dz. We let the function 1 plus z cubed be our u, and getting the derivative of u, or the du over dz, this is equal to 3z squared. Applying the cross multiplication, we have du equals 3z squared dz. And to solve for dz, we will divide both sides by 3z squared, and that is now equal to du over 3z squared. Since we let u equals 1 plus z cubed, our new expression now becomes the integral of z squared over square root of u dz. We have this integral of z squared over the square root of u is the same as u power 1/2 times the equivalent of dz, which is du over 3z squared. And this du over 3z squared is the same as 1/3 times du over z squared. By this, we can cancel the z squared, 1 in the numerator and 1 in the denominator. And we will get 1/3 and place it outside the integral sign. That becomes 1/3 times the integral of 1 over u power 1/2 du. And we will rewrite this into negative exponent form, and that is equal to u power negative 1/2 du. We will now proceed to the process of anti-differentiation. Copy 1/3, u power negative 1/2 plus 1, the denominator is the negative 1/2 plus 1 plus c. For u power negative 1/2 plus 1, that is equal to u power positive 1/2. And our denominator is also positive 1/2 plus c. Get the reciprocal of the denominator 1/2, and that is equal to 2 over 1. Multiply that to u power 1/2. That becomes 1/3 times 2u power 1/2 plus c. Multiplying 1/3 and 2u power 1/2 is equal to 2/3 u power 1/2. We will now plug in the function u equals 1 plus z cubed. That's why our answer is 2/3 times the quantity 1 plus z cubed power 1/2 plus c. In this example, the process is not quite long because we were able to cancel directly the z squared. How about if the derivative of the function does not occur in the integrand? How to apply the substitution method? Let us now consider the next example. In this given, if we will follow the same procedure in example number 1, we cannot easily cancel some variables. The derivative of the numerator is 5x power 4, and the derivative of the radicand of the denominator is 3x squared. Meaning to say, we cannot cancel any of those directly. So we need to devise another method for us to integrate using substitution. We let u equals x cubed plus 5. And from this, by applying the additive inverse of positive 5, x cubed is equal to u minus 5. Take note of this. So we will now get the du over dx, and that is equal to 3x squared. The du is 3x squared dx, and the dx is du over 3x squared. Our new expression becomes the integral of x power 5 over square root of u dx. And this is equal to the integral of x power 5 over u power 1/2, and the dx is du over 3x squared. We can take 1/3 as a constant, and for our x power 5 and x squared, we can cancel the x squared, and the x power 5 becomes x cubed. The expression now becomes 1/3 times the integral of x cubed over u power 1/2 du. Take note that we let x cubed equals u minus 5. Therefore, we will substitute x cubed for the numerator by u minus 5. The integrand now becomes u minus 5 over u power 1/2 du. After that, we break down the integrand into u over u power 1/2 minus 5 over u power 1/2 du. U over u power 1/2 is equal to u power positive 1/2. And 5 over u power 1/2 is the same as 5 times u power negative 1/2. We will now apply the process of anti-differentiation. Copy 1/3. For u power 1/2, that becomes u power 1/2 plus 1 all over 1/2 plus 1 minus 5. For u power negative 1/2, that becomes u power negative 1/2 plus 1 over negative 1/2 plus 1 plus c. We will simplify these two terms. The u power 1/2 plus 1 is the same as u power 3 over 2. And that u power negative 1/2 plus 1 is equal to u power positive 1/2. After that, get the reciprocal of 3 over 2 and multiply that to u power 3 over 2. And that is equal to 2/3 u power 3 over 2. And the reciprocal of 1/2 is positive 2. So we have 2 u power 1/2. Multiplying negative 5 and 2 u power 1/2 is equal to negative 10 u power 1/2. Before we will substitute the value of u equals x cubed plus 5, we will first distribute 1/3 to the binomial. 1/3 times 2/3 u power 3 over 2 is equal to 2 over 9 u power 3 over 2. 1/3 times negative 10 u power 1/2 is equal to 10 over 3 u power 1/2 plus c. This time, we will plug in the value of u, which is x cubed plus 5. Our final answer is 2 over 9 x cubed plus 5 raised to 3 over 2 minus 10 over 3 x cubed plus 5 raised to 1/2 power plus c. For this given, recall that the integral of e power x dx is equal to e power x plus c. We let u equals 3x, so du over dx is positive 3. And du is equal to 3 dx, so dx is equal to du over 3. By letting u equals 3x, our integral becomes the integral of e power u dx. And that is equal to the integral of e power u, substituting dx by du over 3. So we have e power u times 1/3 times du. Getting 1/3 as a constant, so we have 1/3 times the integral of e power u du. Applying the theorem that I have mentioned earlier, so we have this. The integral of e power u is e power u plus c. So we have 1/3 e power u plus c. We will now change u by 3x. Our answer is 1/3 e power 3x plus c. For us to evaluate the integral of 2 power 4x dx, we need to recall this theorem. The integral of ax dx is equal to a power x over ln a plus c, where a is greater than 0 with a not equal to 1. We let u equals 4x, so du over dx is positive 4, and du is 4 dx, and dx is du over 4. By changing the value of dx equals du over 4, our expression becomes 1/4 times the integral of 2 power u du. Let us now apply the theorem applicable in this form. The integral of 2 power u du is 2 power u over ln 2 plus c. Multiplying this by 1/4, so we have 2 power u over 4 ln 2 plus c. By changing u by 4x, so we have 2 power 4x over 4 ln 2 plus c, or 1 over 4 ln 2 times 2 power 4x plus c. The theorem number 3 will help us evaluate the integral of 1 over 2x minus 1 dx. the integral of x power negative 1 dx is equal to the integral of 1 over x dx, and that is ln absolute value of x plus c. We let u equals 2x minus 1 and dx is du over 2. The integral of 1 over u dx is equal to the integral of 1 over u times du over 2, and that is equal to the integral of 1 over u times 1/2 du. Therefore, we arrive at 1/2 times the integral of 1 over u du. And from the theorem, the integral of 1 over u du is equal to ln absolute value of u plus c. Plugging in u equals to x minus 1, the final answer is 1/2 ln the absolute value of 2x minus 1 plus c. To compute the antiderivative of a trigonometric function through substitution, kindly recall the following theorems. We will now evaluate the integral of cosine 4x plus 3 dx. We let u equals 4x plus 3, du over dx is 4, du is 4 dx, and dx is du over 4. The integral of cos u dx is equal now to 1/4 times the integral of cos u du. Using the theorem of the integral of cos u du, our answer is 1/4 sine 4x plus 3 plus c. The integral of sine x cos x dx has two cases. We can use sine x as our u, or we can use cos x. For the first case, we will use c sub 1 and c sub 2 for the second case. For case 1, let u equal sine x, du over dx is negative cos x. Du is negative cos x dx, and dx is du over negative cos x. The integral of cos u dx is equal to the integral of cos u times du over negative cos u. We can cancel out the cos u and the negative cos u, and the answer is negative. The integrand now becomes negative u du. Applying the rule of antidifferentiation, so we have negative of u power 1 plus 1 over 1 plus 1 plus c sub 1. And it is equal to negative of u squared over 2 plus c sub 1. Substituting u by sine x, so we have negative sine squared x over 2 plus c sub 1. For case 2, we let u equals cos x, so du over dx is sine x, du is sine x dx, and dx is du over sine x. The integral of sine x u dx is equal to the integral of sine x u du over sine x. We cancel out sine x, so we have the integral of u du. It becomes u power 1 plus 1 over 1 plus 1 plus c sub 2. And that is equal to u squared over 2 plus c sub 2. U equals cos x. That becomes cos squared x over 2 plus c sub 2. Even if we have two answers, we can still reconcile them by letting some variable. For us to reconcile these two answers, we will let c sub 1 equals 1/2 plus c sub 2. We will now equate them to show that they are equal. We have negative sine squared x over 2 plus c sub 1 equals cos squared x over 2 plus c sub 2. Substitute c sub 1 by 1/2 plus c squared. That becomes negative sine squared x over 2 plus 1/2 plus c sub 2 equals cos squared x over 2 plus c sub 2. We can cancel the common c sub 2. The remainder becomes negative sine squared x over 2 plus 1/2 equals cos squared x over 2. We will multiply both sides by positive 2. That becomes negative sine squared x plus 1 equals cos squared x. Additive inverse of negative sine squared x is positive sine squared x. So we have 1 equals cos squared x plus sine squared x. And by using the Pythagorean identity, cos squared x plus sine squared x is 1. Therefore, our two answers are equal. For the inverse circular function, in integration by substitution, we will just focus on the three theorems involving the antiderivatives of inverse circular functions. We will use theorem number 1 to evaluate the integral of dx over the square root of 16 minus x squared. Take note the expression inside the radical sign a squared minus u squared. In the given 16 minus x squared, u squared is x squared. So by extracting the square root, u is equal to x. Du over dx is 1. So we have du is equal to dx. And our a squared is 16, therefore a is positive 4. Using the formula of the theorem, arcsine of u over a plus c, our u is x and our a is 4. Therefore, the answer is arcsine of x over 4 plus c. To evaluate the integral of 3 over 25 plus x squared dx, we will utilize theorem number 2. The crucial part is the denominator a squared plus u squared. In the given, a squared is 25, so a is 5, and u squared is x squared, so u is equal to x. Du over dx is 1, therefore du is equal to dx. The integral now of 3 over 25 plus x squared dx is the same as by writing the integral of 3 times 1 over 25 plus x squared du. Why du? Because we changed dx by du because they are equal. Since 3 is a constant, then we will get 3 out of the integral sign. That becomes 3 the integral of du over 25 plus x squared. This is now in the form of theorem number 2. We will apply the formula 1 over a arctan u over a plus c. So we have 3 times 1 over our a is 5, so we have 1/5 arctan. Our u is x and our a is 5, so we have x over 5 plus c. Multiply 3 and 1/5, so we have 3/5 arctan x over 5 plus c. We need the third theorem to evaluate the integral of our given number 3. Again, look at the radicand u squared minus a squared, and the given is 4x squared minus 1. So u squared is 4x squared. Extracting the square root, so u is 2x. Du over dx is 2. So du is equal to 2 dx, and dx is du over 2. And the a squared is positive 1. So the square root of positive 1 is 1. So we have a equals 1. We will now rewrite the given in this form. The integral of 8 over. Why we have u over 2? Because u is equal to 2x and x is just half of the u. Therefore, we will just change x by u over 2. And the square root of u squared minus a squared times dx, we will change dx by du over 2. And that is equal now to 8 times the quantity 1 over u over 2 square root of u squared minus a squared du over 2. We can cancel out 2 below the du and 2 below the u. Our expression now becomes 8 times the integral of 1 over u times the square root of u squared minus a squared du. Applying the theorem, that is equal to 1 over a is 1 over, and our a is 1, so 1 over 1. Arc second, u over a, our u is 2x, our a is 1. So we have 2x over 1 plus c. 1 over 1 is 1, arc second, 2x over 1 is 2x. Multiply 8 to the expression inside the bracket, that becomes 8 arc second 2x plus c.